In this problem, we're going to make a balanced chemical reaction from a word problem. So go ahead, read through this, and pause now. Okay, let's take a look. So, in a blast furnace, iron 3 oxide. So, iron 3 oxide. Remember, oxide, IDE ending tells us it's monatomic, and we know that oxygen will typically have a -2 charge because that gets to be isoelectronic with the noble gas. So we'll have iron 3 plus O2 plus 2 minus. We can use the crisscross method, or we can think about the charges to come up with what the ratio should be. And when we do that, we get iron 2 O3. So Fe2 O3. And let me just clean that up. Iron 2O3. This is actually going to be rust, which is a solid. If you knew that, you would write it down, and if you didn't know that, well, you could probably still guess that it's probably going to be a solid, but we're not going to hold you to that yet. So, iron 3 oxide and carbon monoxide. Notice that we're talking about carbon and oxygen, which we already expect to be a covalent bond, or a molecular bond, whichever way you like to say it, because they're both going to be nonmetals. And we'd be right. And the nomenclature helps infer that even further, because remember, we only use the mono prefix when it's going to be something like a covalent bond or a covalent molecule, because we have to describe how many there are, since the charges aren't going to be present and aren't going to tell us. So carbon monoxide, we know carbon monoxide is a gas, produce, it's going to be my arrow, carbon dioxide gas. So carbon, di means 2, carbon dioxide gas, and iron. Now we're talking about a blast furnace, and we're making iron, so I'll bet you figured out that it's going to be a solid for that one as well. That's going to be our unbalanced reaction. Now what we need to do is move on to step 2, where we balance our atoms and adjust our coefficients. So I like to make my little sidebar where I say I have iron, I have oxygen, and I have carbon. Iron, oxygen, and carbon. Same deal over there. I'm starting out with 2 irons. I'm starting out with 3 plus 1 is 4 oxygens, and I've got 1 carbon. Over on this side, I have 1 carbon. I have 2 oxygens, and I've got 1 iron. Now this is the easiest thing for me to balance in the end, so I'm going to do it last. This is the next easiest, so I'll probably want to do it last too. I want to focus on getting iron and carbon dioxide to balance up a little bit. So let me go ahead and, well, let's see. I might as well multiply this by a 2 right now, even though I'm going to tweak it later on. I can see that I need 2 of them just to match up to this 2. I have 3 oxygens and this one. That gets me, let's see, 4 oxygens like I have here. So let's go ahead and double the amount of carbon dioxide I've got. We'll redo our count over here. So carbon, I now have 2 times 1 is 2. Oxygen, I have 2 times 2 is 4. And it didn't affect my count of iron at all. Come on over to this side. I have carbon monoxide. Now I can double that. That gets my carbon corrected. So now, carbon, I have 2. Oxygen, I've got 2. Plus 1, 2, 3 more. So I've got 5. So what I need to do is I need to have this ratio come up a little bit. Now let's see. So to fix my oxygens, I can go ahead and increase the number of carbon dioxides I have. I'll jump it up to 3. Now that's only going to change my oxygen and my carbon, so I'll just change those ones. So now I have 3 carbons, and I have 6 oxygens. I come over here, I'll bump up my carbon monoxide 1 more as well to fix my carbons. That gets me to 3 carbons, and gets me to have 3 oxygens plus 3 more gives me 6 oxygens. That's my balanced chemical reaction for this. So iron 2, oxygen 3. So iron 2 oxide, iron 3 oxide, and carbon monoxide are going to yield my 3 carbon dioxides and 2 units of iron. Okay, so that's my balanced chemical equation for that. Let's give it a quick double check to make sure that I have everything correct on it. I have 2 irons, and I have 2 irons. I have 3 and 3 more oxygens, give me 6. I've got 3 times 2 is 6. I've got carbon, I've got 3 of these, and I got 3 of them over on this side. So that's looking correct to me. We've already specified our states of matter, so that would be our balanced chemical equation for this problem.